Welcome to this video on marine engineering. Today we will discuss cooling water treatment on ships, specifically focusing on the role of nitrite-borate in products like Dieselguard and Rocor. Effective water treatment is crucial for maintaining the performance and longevity of marine diesel engines while at sea. You might wonder what NB stands for in these products. It refers to the nitrite-borate cooling water treatment, specifically formulated for marine diesel engines. This treatment is essential for maintaining the health of your engine's cooling system. In this video, we will cover key areas: engine room water chemistry, the importance of corrosion protection, and the necessary procedures for shipboard testing and maintenance. These topics are fundamental for ensuring your cooling systems remain operational and efficient. By the end of this video, you will understand the purpose of NB inhibitors, how to monitor water parameters, and how to apply best practices to prevent common issues like corrosion and scale. Mastering these objectives is vital for any marine engineer responsible for engine maintenance. So what is the chemistry behind it? Nitrite acts as the primary corrosion inhibitor, while borate buffers the pH and maintains alkalinity. Additional organic inhibitors provide further protection from mixed metal systems. These components are carefully combined to protect closed cooling loops in demanding marine environments. Using the right chemistry ensures the internal surfaces of the cooling system remain clean and protected from degradation. Why is this treatment so essential? Without it, your engine faces serious risks: electrolytic corrosion, rust, cavitation damage, increased erosion, and scale buildup that hampers heat transfer. These issues can lead to engine overheating and significantly higher maintenance costs over time. Proper treatment, combined with the use of distilled water rather than raw tap water, is a standard best practice to avoid these pitfalls. Ultimately, poor water chemistry directly impacts shipboard operations, leading to cooler failures, cylinder liner corrosion, and reduced engine efficiency. Let's explore how nitrite works. It reacts with metal surfaces to form a protective oxide film, which is essential for preventing electrochemical corrosion and reducing pitting. This protective film also helps minimize cavitation attack, which can be devastating to engine components, and effectively extends the life of those parts. An important feature is that this protective oxide film is not static. It will continuously regenerate as long as you maintain a sufficient concentration of nitrite in the system. Next, let's look at the role of borate. It acts as an alkaline buffer to help maintain the correct pH level and neutralize any acidic contamination that may enter the system. By keeping the system neutral or slightly alkaline, borate prevents acid-base corrosion and helps support the overall effectiveness of the nitrite treatment. The combined result of these functions is stable cooling water chemistry, which translates directly to longer, more reliable equipment life for your ship's systems. Dieselguard NB and Rocor NB are versatile treatments used in various marine applications, including main engine jacket water and auxiliary cooling systems. They are also suitable for piston cooling water, central cooling, compressor cooling, and other auxiliary machinery cooling circuits, carrying approvals from major engine manufacturers. Maintaining optimum corrosion protection requires testing your cooling water for specific parameters. These recommended values serve as a baseline for system reliability. We will now discuss nitrite control, with a recommended range of 1,000 to 2,400 parts per million, measured as NO2. If your nitrite levels drop too low, the protective film weakens, allowing corrosion to accelerate and leaving metal surfaces exposed to damage. Conversely, maintaining nitrite levels that are too high is unnecessary and could lead to chemical waste, increased costs, and the formation of unwanted deposits. pH control is equally vital, with a recommended range between 8.3 and 10.0. Borate is the primary agent that helps maintain this stable pH environment. If the pH falls too low, you risk acid corrosion and increased pitting. If it becomes too high, you may face scaling issues or a chemical imbalance. Finally, monitor chloride levels, keeping them below 50 parts per million. High chlorides from seawater leaks or poor makeup water can cause a severe pitting and corrosion. Now let's look at the practical side of shipboard testing. A typical weekly routine involves collecting a fresh cooling water sample and testing for nitrite, pH, and chlorides. Once testing is complete, record the results, adjust the chemical dosage as needed based on those findings, and ensure all records are updated in the engine room logs. Consider an example scenario. Your tests show 700 ppm of nitrite, a pH of 8.1, and 20 ppm of chlorides. How do you assess this? Your assessment would show that the nitrite level is too low and the pH is slightly low, but your chloride levels remain well within the acceptable limit. The appropriate action here is to add the recommended dosage of Dieselguard NB or Rocor NB and then retest the system after allowing for sufficient circulation. Proper cooling water treatment offers significant operational benefits, including reduced corrosion, minimized cavitation, improved heat transfer, and lower overall maintenance costs. These benefits ultimately lead to increased engine reliability, longer equipment life, and improved operational efficiency for the ship. Marine engineers should follow best practices, Always use distilled or demineralized water, maintain nitrite levels, test regularly, and monitor for any chloride contamination. Keep thorough records of your readings, investigate any abnormal trends immediately, and ensure you are only using approved treatment chemicals. To wrap up, remember that NB stands for Nitrite-Borate. Nitrite provides the essential corrosion protection through oxide film, while borate buffers the pH for alkalinity control. Maintain your nitrite between 1000 and 2400 ppm, pH between 8.3 and 10.0, and chlorides below 50 ppm. Regular testing is the foundation of reliable operation. Thank you for watching this guide on cooling water treatment. Stay tuned for more content on marine engineering. Be sure to subscribe to the Seaman channel for more technical insights and updates on marine engineering practices. We hope this video provided you with a clear understanding of the importance and application of nitrite-borate treatments in your daily duties.